Okay, in this last video for Chapter 5, we want to talk about the concept of density. We spent a lot of time in the lab looking at the concept of density. I just want to quickly go over some of the major points of the concept and do a couple of example problems. Density is defined as the mass of a substance per a given volume of that substance. So the mass per unit area, or unit volume, sorry. The mass per unit volume. So we're looking at the density of a substance is how much mass is in each piece of the volume. Units for density can be very different. It depends on what units we're using for mass and what units we're using for volume. This is a derived unit, just like volume is a derived unit. Now this is even derived another step as part of an equation. The equation for density, one equation that you probably learned and used before, density equals mass divided by volume. So you can rearrange this equation any way that you would like. Density times volume equals mass. Mass divided by density equals volume, or density equals mass divided by volume. Some of you learned a method with a triangle to help you do that in middle school. When we look at the units for density, we're looking at the common units of grams per milliliter. That's going to be our most common one we're going to use in this class because we'll generally use grams for our balances and milliliters from our graduated cylinder. We could also do grams per centimeter cubed, kilograms per liter, basically any mass unit divided by any volume unit. Let's look at a couple of examples here and then we will sort of wrap up this chapter. Sample of kerosene weighs 36.4 grams. Its volume is measured at 45.62 milliliters. What is the density of the kerosene? So we know density equals mass divided by volume. This is where knowing our units is so important. Density, 36.4 grams is a mass. 45.62 milliliters is a volume. So we want to take this and do the division. So 36.4 divided by 45.62. That gives us an answer in our calculator of 0.797896 grams per milliliter. Now we know significant figures are important, so we do need to round the correct number of significant figures. We're going to look at this first number, 3 significant figures. The second number, 4 significant figures. We're dividing, so we round to the least number of significant figures, so 3. So our answer can have 3 significant figures. We'll round based on the 8. So our correct answer is 0.798 grams per milliliter. Okay, let's look at a second example. Acetone, the solvent in some nail polish removers, has a density of 0.791 grams per milliliter. What is the volume of 25 grams of acetone? Pause the video here for a second, try the problem, and then press play again once you've tried it to see if you've done it correctly. Okay, we'll start with the equation. Density equals mass divided by volume. This time I'm trying to solve for volume, so I'm going to do the algebra first. Density times volume equals mass, cross multiply. Think of it as density divided by 1, so mass times 1 equals density times volume. Volume, therefore, is mass divided by density. So the volume in this case will be the mass, 25.00 grams, divided by the density, 0.791 grams per milliliter. Dividing by something is the same thing as multiplying by the reciprocal. So you can think of this units-wise as grams times milliliters divided by grams, the reciprocal of grams per milliliter. Grams cancels, you get milliliters. Do this in our calculator. 25.00 divided by 0.791. Numerically, this comes out to 31.6056 milliliters. The grams canceled. We solve for milliliters. Now significant figures. We have 4 significant figures here, 3 here. Remember the 0 out front is leading, so it is not significant. So we'll have 3 in our answer, so 31.6 milliliters.